The last topic for this chapter is equations that are reducible to quadratic equations. So what this means is you take an equation that isn't strictly an x squared or a quadratic, and you do some form of manipulation or substitution into it to reduce it to a quadratic, and then you solve it like you would a quadratic by factorizing it or using the quadratic formula, and you then use that to work out what your variable is. It'll make more sense once you see what we're doing. It's often called a u substitution because a lot of the time what we do is substitute u in for some other term so that our equation becomes a quadratic. So looking at this first example, so solve x plus 1 all squared plus 3x plus 1 minus 4. The way we do it is to let u equal x plus 1. Now, you don't have to use u, that's just the convention. You can use anything you like. But whatever you use, you must say this part. You must say let u equal to whatever you're substituting in for. You can't just go straight to u squared plus 3u minus 4. Okay? So first tell them what you're doing and then rewrite your equation. So wherever x plus 1 is, we're using u. So that means that u squared plus 3u minus 4 is equal to 0. And now what I have is a quadratic, and I know how to solve this quadratic because I've been doing it for a long time. And we get u plus 4u minus 1 is equal to 0. And so we know that u must either equal 1 or negative 4. But, and here's the but, they don't want to know what u is. They want to know what x is. And the biggest mistake kids make is to stop there. So don't. But you don't have to do the underline and the exclamation points. But u also equals x plus 1. So we know that 1 is equal to x plus 1, and therefore x is equal to 0. Or we know that negative 4 is equal to x plus 1, and therefore negative 5 is equal to x. So you've got two solutions to your original equation. Now you could have expanded it out and found those solutions as well, but expansion won't always work. So take this second example. We've got 3 to the power of 2x minus 10 times 3 to the power of x plus 9 is equal to 0. So traditional methods, we can't solve this. That's not in any form that we can use. But what we can do is replace 3 to the power of x with something else. Again, I'm going to use u. So then our equation is now u squared, because 3 to the power of 2x is 3x all squared, minus 10u plus 9 is equal to 0. And again, back to our quadratics, we know how to solve this. That is u minus 9, u minus 1 is equal to 0, and therefore u equals 1 or 9. But we know that u is equal to 3 to the power of x. So 3 to the power of x equals 1, or 3 to the power of x equals 9. Now, they're equations I can solve, because 3 to what power is equal to 1? Well, it's 3 to the power of 0. And 3 to what power equals 9? Well, that's the power of 2. Okay, so by reducing it to a quadratic, I learn how to solve it. Something slightly different, we've got x minus 6 over x equals negative 1. Now, the only condition you're going to have on this equation is x can't equal 0, because 6 over 0 is undefined. Alright, so because we know that it's not equal to 0, what we can do is then multiply through by x to get rid of the fraction. So if we multiply through by x, then we end up with x squared minus 6 equals minus x, which with some manipulation, bringing the negative x across, becomes x squared plus x, minus 6 is equal to 0. And again, we're back to solving a quadratic. So that's x plus 3, x minus 2, and so x is either equal to 2 or negative 3. Okay. And the last one that we have here, so we've got y to the power of 4 minus 6y squared plus 8 is equal to 0. So if you want to do the u substitution again, you can, or you can try factorising it straight from the y to the power of 4. It's up to you. I'm going to show you the u substitution just because that tends to be something that leads to less errors. So I'm going to let u equal y squared. So if u equals y squared, then u squared minus 6u plus 8 is equal to 0. So again, factorising, we get u minus 4 and u minus 2 are equal to 0, and u equals 2 or 4. And then you go back and you substitute in your y squared. Okay, so this is telling us that y squared equals 2 or y squared is equal to 4. Remembering that because it's squared, we don't know if we have a positive or negative, so it's plus or minus root 2, or y is equal to plus or minus 2. So that's what you need to do exercise 9.6. Do as much as you need. For a lot of you, you won't need to do a lot, but make sure you do the different types. Good luck, and I'll see you in class.